Okay, hello everyone. My talk is Hadron Spectroscopy. Actually, a lot of the topic can be covered in this talk, like Hadron, Charmonium, and Botonium. We already have a lot of the interesting results from the different experiments have been presented in the parallel session. So due to the time limit, in this talk, I will concentrate on the Charmonium. Charmonium-like particle state, and I apologize that I could not cover all of the results here. So, okay, as we know, in experiment, we have observed the hadron with the quark and anti-quark meson or a 3-quark baron, which can be very decrypted with by the quark model. But due to the confinement and QCD require the stable hadron needed to be covered with. Also, QCD predict the existence of the hybrid gluon or multi-quarks. Search for this exotic can provide a directory test for QCD. So now the question is, can we find these exotic hadrons? So actually, as we know, we have a very long history to search for the exotic hadrons. So no solid conclusion was reached in the past few decades. Until recently, we have some hint on the Charmonium-like or Botonium-like state. Okay, in this talk, results from the Bell, BABA, BESS3, and LSCB as well as results from KVOC, CDFR, CMS, Atlas will be covered, will be reported. So okay, now as we know, Charmonium spectroscopy can play an important role in establishing the QCD as a theory of the strong intervention. Our state below the threshold below the time threshold have been observed. Also, it is found that the QCD can decrease the spectral waves very well. But however, above the threshold, there are a lot of the states are missing. Also, in the last decade, we observe a lot of the new state above the threshold. This state always can decay to a Charmonium in the final state, but it's not an obvious Charmonium particle. So the question is, what are they? There are many theories, speculation. It can be the conventional Charmonium, it can be hybrid tetraquark molecule, or it can be non-resonance at all. So now we're beginning from the S3872. Actually, this particle is very established. It was first observed by Bell and confirmed by several experiments. The JBC is 1 plus. Plus is a definitive determination by the LSCB. And it can produce in the B decay in the proton, antiproton, proton, or proton, antiproton collision. Since the JPC is 1 plus plus, so it was expected to produce from the radiative transition or from the excited Charmonium or Charmonium-like particle. It can be searched in the multi-pion transition to the Charmonium, radiative transition to the Charmonium, or can be in the double D final state. So BESS3 have reported observation of the E plus E minus to gamma S3872. The method, the mass and wave, is consistent with the PDG. The method causation is found to be one order higher than the non-reactive QCD calculation for the continued process. Also, the line shape suggests that it comes from the radiative transition production of the Y40 to 60, but it's not concluded yet. So if we assume the two-pion transition to the depth side is 5%, and then we can get very large ratio of the radiative decay on the two-pion transitions. And this large decay indicate that there are some is inconsistent as we expected from the conventional Charmonium. If it's really from the radioactive decay, it can be a new decay model of the Y4260. Also, together with the JC single pion transition or the JC 3900, it was suggested that there are some commonality in the nature of the Y4260, JC 3900, S3872. The nature of the the nature of the S3872 is still unclear. At the beginning of its discovery, it have a lot of the theory speculation. But in experiment, we measure the different production and different decay rate to study its natures. Recently, the LSB have a report with present the result of its radioactive decay to Saipan and Jepsai. The ratio, the decay method ratio is consistent with the Baba and Bell experiment, but and also it was suggested that it's rule out is not pure the DD bar molecule. Also, we have observed, we have a method is branch ratio decay to Jepside rho and Jepside omega in the comparable branch ratio, which indicate dramatic fluctuation in the isospin symmetry. So our experiment evidence strong suggests that it's a mixture of the DD bar molecule or is a conventional Charmonium state. Now we move to Y state. Y4260 is first discovered by the Baba experiment from in the pi Jepside final state. It was confirmed by the Bell calibration. Also, Bell have observed a new structure of the 4008 with 4.4 sigma, but the Baba data didn't support this observation. This event is treated as the side plan tail, or is from the non-contribution from the non-pi non-resonance pi jet side. Bell's finally, Bell's last updated result show a good agreement with the Bell's previous result is confirmed the existence of the two structures. The inconsistency of the Y4008 can be clarified by the best 3 data. So now, in the analysis of the final state of the Saipan pi, both Bell and Baba have observed the structure of the Y4360. Also, Bell observed a new structure of the 4660. With the Baba updated result have showed a good agreement with the Bell's result, and so the existence of the Y4260 have been confirmed. The Bell's preliminary result with the full data set show a good agreement with the previous result. Since there are Rothstein events accumulated in the region of the Y4260, so analysis with the Y4260 fit is included, and so the significance of the Y4260 is only 2.1 sigma. So in best 3 can precise measure the causation of the precise measure the product causation of the E plus E minus and pi plus pi minus Jepside. With the line shape measurement is ongoing. It can be used to validate the existence of the Y4008. So as we know that HC is the spin single rate, and it's important to know is the production causation in the 2 pion transition production. So actually, KVOC have a report with significant pi plus pi minus HC production in the data of the 4170 MeV. But whether this significance production correlated with Y state or others Charmonium state is unclear. So best 3 have performed analysis of the pi plus, E minus to pi HC, and the method causation is at the same order of the pi plus pi minus Jepside, but you can see with the very different line shape. So we observed the local maximum is observed at 40 to 30. Also, a very broad structure is observed in the 4400. So is the production correlated to the Y state is unclear. So we need more data around the 40 to 30, around above the 40-100 will be helpful to understand the production. Another interesting is Y40 to 60 is very close to the omega KCJ, so it's important to measure its production in the omega KCJ. Best 3 have performed the analysis of the E plus E minus to omega KCJ, and it observed clearly signal at 40 to 60 and 40 to 30 data, but there are no evidence at 4360 data. So the line shape, so the method causation so very inconsistent with the Y40 to 60. And when a better Wigner fit gave a very narrow structure at 40 to 30. So there's the interesting question is are there any thin structure at 40 to 30 in the Y40 to 60? Now I give a brief summary of the Y state. In the quark model, we have a file state. We expected to have a file state between 4 to 4.7 GeV, but in experiment we observed the 7, where all the 3 established Y state have a very similar property. It was narrow structure above the time threshold, or is strong coupling to the time morning state, but it was not any evidence in the open time process of R value scanned. Largest best 3 sample R scan sample can help to convert or improve this measurement. Also, in the E plus E minus 2 pi pi HC or omega KC0 cross-section have been measured. The inconsistent line shape with the Y40 to 60 measure situation is more complicated. So there are probably a thin structure at 40 to 30, which can strong coupling to the omega KC0. The nature of the Y state is still unclear, needed to be understood. Now we move to JC particle. Okay, JC particle is regarded as the most promising way to search for the exotic hadron, since it can decay to the Charmonium or it can decay to the DD bar final state, so which indicate it contains a hidden CC bar pair. It also have an electric charge, so which indicate that we have 2 more wise quarks. So this kind of quark, this kind of state, at least they have 4 quarks, and it's not a conventional meson. JC can be observed in the single pion transition to a Charmonium state or in the DD bar final state. It can be searched in the experiment like BESS or B factory with associated of the pi, or it can be searched in the B decay like LHCb or B factory. So in the study of the E plus E minus to depth size pi plus pi minus, both the BESS 3 and Bell have observed the structure at 3900. 3900, the method, the mass of the wave is very is consistent very well. And when the result is converted shortly by the Curiosity's data. Since the JC 3900 mass of the JC 3900 is very close to the DD star, so it's interesting to know if it can be decayed to a DD star. So the BESS 3 performed the E plus E minus 2 pi DD star, and the structure is observed in the DD bar mass threshold. The method mass and wave is consistent, but with 2 sigma and 1 sigma below 2 rows of the JC observed in the pi pi GSI. So, so the better pi angular distribution, whether the JP is 1 plus, So now the interesting question is, are these JC 3900 and JC 3885 our sense state? So if we assume that we are a sense state, we can get a decay weight or the decay weight to a D star, and the depth size is 6, so which indicate very large non-DD bar coupling. So with a normal value suggests we should have a very different dynamic in the Y4260 and JC 3900. Now, since JC 3900 is well established, so now the important question is isospin partner neutral JC if it exists. The curiosity so the evidence of the neutral JC 3900 with the 3.5 sigma, and best have performed analysis with E plus E minus to pi 0 depth size. The JC neutral JC is observed very clearly. The best three preliminary results, so the mass and wave are very close to a neutral JC. So the neutral isospin partner JC 39 is observed. In the analysis of the E plus E minus to the pi plus pi minus SC, best three observe the narrow structure the JC 4230, but they are not significant evident for the JC 3900 to the pi HC. Similar to the JC 3900, this mass is very close to the D star. So best three perform analysis of the E plus E minus to pi D star. The observed line shape is deviated from the phase space decay. The method mass and the wave is very consistent with observed of the JC 4020. If we are the same particle, we can get a very large ratio non-DD bar coupling. Similar to the JC 3900, is interesting question is if the neutral JC 42 is it. So the best three have performed the analysis of the E plus E minus to pi 0 SC. The method causation is half of the vector charge process, which is very agree with the interpretation of the isospin symmetry. Also, it observed a neutral JC for 4020. The mass is method mass is very close to the neutral JC, charge JC's mass. So the neutral partner of the charge JC 4020 is observed. The observation of the neutral JC 3900 and 2040 establish the isovector nature of the JC state. Now we go to the JC 4030. As we know, actually, this is the first observed charge harmonic particle report by the Bell calibration in the B decay to psi prime K pi. But the data so that it can be well decreased by the reflection of the K star, but not contracted to the Bell's result. The existence of the JC 4030 is an open question. Until recently, LSCB have performed 4D model independent amplitude analysis on the same process with the much higher statistical data sample. It established the existence of the JC 4030, and the spin is measured to be 1+. The Bell's updated result confirmed its existence, and the JP is favored to 1+. So, but the mass and the wave of the JC 4040 is in the recent result is much higher than that of the Bell's previous result. So this is the second JC particle observed by the two experiments. The existence of the JC 4030 and for all 4080 have established. With the similar analysis, 4D analysis, amplitude analysis, the Bell calibration report the result of B decay to depth size K pi, and the new structure JC 4200 is observed. The width is very but it's very width. Also, it was suggest that JC 4030 is observed with the with the 4 sigma. So is it of the new JC particle, or is the new decay mode of the JC 4040 need confirmation by others' experiment? Now I give a brief summary of the JC particle. So far we have 3 well established the JC particle. It can be observed in a single pion transition to a harmonic state. It all will decay rate to a DD pi. And single pion transition to a harmonic is unusually indicated largely coupling to a non-harmonic data. The neutral isospin partner is observed, and the iso-vector nature have been built. The JP is 1 plus, but the productions of the visa state is in unclear. We also have 3 JC need 2 more confirmations, JC 4200 and JC 45 and JC 4250 observed in the Bell calibration in the B0 to the K pi KC1. The nature of the JC is unclear. So whether it's a new type of the QCD state or is a dynamic general structure is unclear. But one certain, if we are really a QCD particle, there could not be a conventional harmonic. Now I saw a page for the controversy of the on the B2 KJ5. The CDF was first reported Y4140 and Y4274 in the JSI-5 infant mass distribution, but it was very controversy in the following experiment. Recently, the BABA preliminary result so the data could not be assessed by of the present resonance behaviors. So we need a higher statistic and full Davis port analysis to understand, to confirm the existence. Okay, let's give a brief summary of my talk. Even I didn't say any slide, don't show any slide in the Y hadron, but I want to say that in the Y hadron, there's still a lot of the puzzle and controversy remain to be resolved. In the last decade, we observe a lot of the harmonic or botonic-like state, SVJ or this state. The nature is unclear, but we are not conventional harmonic. We need a high precise measurement and understanding to between the different transition between the different states. We also need the export or the possible decay of this new state to understand its nature. More data, of course, more data at a very central mass energy might shed light in the study. Also, as we know, very strong similarity between the harmonic and botonic system. So we study the CC bar together with the BB bar may help to understand the structures. For experiment, the challenge for the spectroscopy is a high precise measurement. We the high statistic, high precise data, advanced analysis tool to get a high precise result. We also need the different experiment, different production and mechanism to get a global view of the spectrum. And so far, past the experiment like BABA and Bell and BABA, and the running experiment like BEST3 have make remarkable successful and very significant contributor to the harmonic-like state. This experiment can immediately add our understanding of the meson spectrum above the open chance threshold. The coming experiment like the Bell 2 Panda and the updated LSC and other experiment like experiment in the JRIP can promise to have a much more full result on spectroscopy. Okay, thank you.
Thank you. Okay, we can accept several comments or questions.
Okay, you have mentioned the ZC 4020. I think this one cannot be given for granted, in the sense that it is observed looking at the invariant mass distribution of this star bar, and there is a peak close to threshold. But the peak close to threshold you can also get from a resonance which is below threshold. So in this sense, I mean, there is a work, that's why I say that, by Alberto Martinez and collaborators, in which, I mean, he proves, I mean, that this can be nicely interpreted in terms of a resonance which is 20 to 30 MeV below than the 4020. So I would not put that as already something settled. Yeah? I mean, this requires more discussion.
Okay.
And if no one wants to talk, then I want to call your attention, I mean, because all you experimentalists are mentioning the X3872 as a D0, D star 0 molecule. I mean, we theoreticians, I mean, or most theoreticians will tell you that that's not the case, that it requires also the charge components, D plus, D star minus. But anyway, that's a comment.
Any other question? Okay, if there is no more questions, then let's thanks to speaker again.